You want to learn about the subject of forensics. That's good. You probably think of forensics is where the policemen, they just give all their clues to a laboratory. In the laboratory, they just science it up and they come out of there with a conviction. If only it was that easy. Well, it's not, and it requires a lot of understanding to see what goes on in the lab and what goes on all the way between getting the clues and causing a conviction. So, let's get right into it. The textbook is called Criminalistics. Criminalistics and forensics are not the same thing. Criminalistics is the study of criminal activity. It is not the same as forensics, which is the use of science to understand and to find proof of criminal activity. Criminalistics include why people do crime, bad neighborhood or hunger or whatever it is. That doesn't help you solve cases. It doesn't enable you to find proof that the person was guilty. So criminalistics includes a lot more than just forensics. We know what forensics is. It's how to use science to catch criminals. It's also used to exonerate innocents. Some people are proven not to be guilty based on certain evidence that forensics will supply. For the first chapter, first part, first of all, understanding what forensics entails, what it is. Understanding a little bit about how physical evidence is obtained and how it's presented in a courtroom. Also, it's what an expert witness is, because if you're going to be in forensics, you're going to be a forensic analyst. You're going to have to testify in a court, and you do so as an expert witness. So hopefully you'll learn a little bit more about how an expert witness is supposed to act in a court and how they're supposed to behave. So, what kind of science is included in forensic science? The answer is almost all of them. All science. Engineering, physics, computer science, a lot of it is involved. The reason why is that science is the study and the analysis of the way the world is. And as long as criminals are working in the world, all science that has to do with the way criminals work in the world is going to be applied to forensics. Now, there are certain things that are applied more than others, and hopefully we'll learn more about them. But the fact is that just about any one of the sciences, chemistry, biology, physics, you name it, can be applied to criminals and criminal activity. This leads to the question of how do we do science? And you've probably heard of the scientific method. That includes, first of all, observing the situation. You have to see it first. Kind of obvious. Okay, there's the surroundings also. Record the observation. This is very important. You have to record it. Obvious, but you have to do that. Then, after you've analyzed it, you've recorded it, take a look at your records and find the cause and the effect. What caused it and what happened afterwards. After that, you test it. Also very important. You have to know whether your idea works or not. You find the cause and effect, you develop a hypothesis, and you test the hypothesis. But anyway, you would test your explanation of why things work. Why this cause ended up with that effect. And this is very important. It has to be reproducible. You have to be able to reproduce it again, to do it again. Kind of obvious, isn't it? Look at what happened, write it down, then study what you wrote down and see if it's true. What do we need the scientific method for? You can only know this in a relevant way if you know what people did until they came up with a scientific method. What did people do? Observe, right? Going back to the days of Aristotle, observe. They didn't have to observe it necessarily. They relied on other people. And the other people said, oh yeah, there's a green monkey running around in Africa. Well, they believed it. So you can rely on that. So now, as part of your encyclopedia of animal life, you'll talk about a green monkey, even though you yourself didn't observe it. It's not scientific, but they got knowledge of the world. Now, is this trusted? I mean, there's a story. This is almost, but not quite 3,000 years old, where there was a sailor. And he was telling his stories. He was explaining what happened to people who were trying to find out what's going on in other lands. And he said that he visited the island of the two-headed people. Now, we know that two-headed people do actually exist. In the United States, that's Brittany and Abigail. That's a two-headed person. It's caused by Siamese twins that are joined basically at the torso. Two heads, but one body. And there's an interesting legal question. How do they inherit? Suppose you have three boys. One is the oldest brother, let's say. And then we have this two-headed person. Do we split the inheritance three ways? Or do we say, well, since it's just one body, you split it two ways? Interesting question. This Solomonic decision was actually decided by, well, okay, I'm getting off the topic. Anyway, he was telling a story that they got to the island of the two-headed people, and they got to the shore, and there was a jungle right past the beach. And he was reporting being on the island of the two-headed people, and he said, we heard their drums, and they came running out of the jungle, and then we ran. So the listener asked him, but did you see them? Did you see them coming out at you, these two-headed people? And he responded, who waits for that? We just ran. Can you really trust that? Well, in those days, they relied on these stories because they didn't have anything better. We have the scientific method where we do not trust this at all. In those days, they didn't have much of a choice. Recording. Oh, we think that's kind of obvious. But in those days, you rely on memory or someone else's memory. You didn't always write it down. You didn't have to. If you remembered it, that's good enough. Well, we now know that memory can be kind of tricky. It can even implant false memories. It's a different, interesting subject, but the idea is, in those days, why not rely on memory? Finding the cause and effect. Well, this is kind of religious when you think about it, but a lot of times people didn't bother with that. It was just the will of the gods. Why is it when you hit the rock with this metal, you produce sparks? Because that's the rock god fighting with an iron god. They didn't really try to figure out, well, maybe what about different rocks? Would they work the same way? What if it's not iron? They didn't bother with that because that was just the will of the gods. Then you have to test it, see if it's actually true. Well, maybe it just sounds right. You don't have to test it. That's what they used to say. It sounded right. There's an error, Aristotle's error. It held sway in the scientific world for about 2,000 years. Aristotle came up with the idea that if you have two objects, a heavy object and a light object, and you throw them from the top of a building, the heavier object will land first. The heavier object falls faster. Sounds right, and everyone believed it for a long time. But did he actually test it? He did not test it. Only in the times with Galileo, was it tested. It sounded right, so everyone believed it. But Galileo tested it, and he found out that it was actually not true. Lighter objects fall the same speed as heavier objects. And it was easy to observe, but nobody bothered testing it. Nobody bothered observing it. Galileo used the scientific method. Aristotle just thought it out. This is what was going on before scientific thought, before we used science. So it might be obvious to us only because we know what it is. We don't know, we weren't thinking about what people did until then.